Hello everyone, welcome to another engineering tech video. Today we're going to be dealing with exponents, specifically dealing with the exponential laws. Okay, as shown in the screen, the exponential laws, we have 5 of them, and then we have a few which are correlations / dependencies from said exponential laws. All right. Now, what's an exponent? Or rather, yes, an exponent or a power, as it's called. A power is when you have a number that is multiplied in a certain way by itself in a certain number of ways, and this as a whole you call it a power, and this here is the base, and then that right there is the exponent. So the exponent is what defines how many times or how exactly is the base being multiplied by itself. And this is an exponent. We usually call the whole thing exponents to make it simple, because the main focus would be the exponent, which is what defines how this whole power behaves. So we usually just say exponents. All right. Now let's look at the first law of exponents, which is the multiplication law. The multiplication law says if you have 2 powers or 2 exponents that have the same base but have different exponents at the top there, and these 2 powers are being multiplied with each other, then what you can do is you can keep the same base but you add the exponents. So if you have a to the exponent of n multiplied by a to the exponent of m, so you have the same base, but you have 2 different exponents, or even if the exponents are the same, so long as you have 2 powers with the same base being multiplied, you just take the exponents and you add them together there, and you have the answer for your multiplication law. So if we look at an example, it would be something like, maybe if you say you have 3 to the exponent of 4 multiplied by 3 to the exponent of 3. This will simply be 3 to the exponent of 4 plus 3, which is 3 to the exponent of 7. So you've simplified something like that to that. Right. Now the next law that we're going to deal with is now the division law. Remember, division is the reciprocal, or rather the opposite of multiplication, right? So this is how I usually do it. This is how I remember it is, if in multiplication I'm adding, what is the opposite of addition is subtraction. So multiplication goes with addition, and then division goes with subtraction. So when I multiply, I do addition, and then the opposite of multiplication is division, as well as the opposite of addition is subtraction. So the division law says if I have again 2 powers with the same exponent, with the same base, but these powers have different exponents or the same exponent and they're being divided with each other, what you do now is you're going to take the same base and you simply subtract the exponents. So you see what I said, in multiplication we're taking the same base and adding the exponents. Now since we're doing the opposite of multiplication, which is division, we are taking the same base and doing the opposite of addition, which is subtracting the exponents. This is the division law. And if you had an example, it would be something like 2 to the exponent of 8 divided by 2 to the exponent of 4, which will give you 2 to the exponent of 8 minus 4, which is 2 to the exponent of 4. So you've simplified something like that into just one power, which just shows how the two will behave when you look at said equation. Now we have the third law, which is now when we're dealing with an exponent of an exponent. This is what I mean about that. Say you have this exponent here, but said exponent is raised to another exponent like so. Now you have the exponent of an exponent. Now in this case, what just simply happens is you apply the same rule that you used to apply when you were doing brackets in grade 10, where if you have a bracket, you multiply what's outside with what's inside. In this case, since we're working with just the exponent, that means you're going to multiply the exponent outside with the exponent that is inside. So this will give you an exponent a to the exponent of n times m. And this, if we play around with it, just simply means I can switch it around again and say, okay, I can put a to the exponent of m inside and put n outside. Why? Is because even if I multiply n to m, I'll still get the same thing. So this and that, even though the bracket has different exponents, gives you the same answer. So they essentially are the same. Okay. The next exponential law that we're going to deal with is now if we have two numbers as the base and we have one exponent, right? Say now you have a and b, all of the two, remember when it's written like that, it's multiplied, a times b all to the exponent of m, like so. Now what happens here again is the same rule that we did in law number 3, where we multiply the exponent outside with the exponent inside. But in this case, remember, anything that remains to the exponent of 1 doesn't change, right? Same as something multiplied by 1, it doesn't change. Even when you have something to the exponent of 1, it still doesn't change. 1 usually doesn't change numbers. So if I have something like this and I have one exponent outside, what do? I multiply the one outside with the ones inside. So I will have on a, it will be 1 times m, which is just m. So you'll have a to the exponent of m. Then this is multiplied by, then you'll have b again, which is going to be 1 times m. And then it's b to the exponent of m. So that's how you deal with two sets of bases all to one exponent. You just multiply in and you do so. Even if you had these exponents as a squared, say you have something like a to the exponent of 2 times b to the exponent of 1, like so, all to the exponent of m. The m will multiply in, same way. So this time around it will be m times 2, which is going to be 2m. So you'll have a to the exponent of 2m times b to the exponent of 1 times m, which is just m. So it's the same thing. The only thing that changes is the coefficient, because you have a different thing written on exponent of a. That's the fourth rule right there. And then now in the fifth rule is when we're dealing with the same bracket exponent, but this time around the bases are not multiplied, but rather they are divided. But again, you apply the same rule, right? So let's say you have a over b, all of this to the exponent of m. Remember again, a, since the a doesn't change, it's a to the exponent of 1, and it's b to the exponent of 1, and then you multiply in. This time around, you don't just multiply at the top, it multiplies the one at the top and it multiplies the one at the bottom. And then you'll have it as a to the exponent of m divided by b to the exponent of m, like so, right? This, again, if you had something like a to the exponent of x, let's say, all divided by b to the exponent of y, all of it to the exponent of m, would be the same thing. It doesn't change. The m will multiply the x and the y. And then what you will have at the end is you'll have a to the exponent of x times m divided by b to the exponent of y times m. And that would be your answer. Those are the 5 rules of exponents. Now, the other rules that come from those will be the correlations or the dependencies that will have different rules, but they come or depend on the rules that come from the first 5. So the ones that I've just done with you guys are the 5 core rules. And then in the next video, we're going to be dealing with the correlations from the laws or the dependencies from the laws. And then we will do a few examples to further explain exponents. That's it for this video. Thank you for watching. Please like and subscribe to my channel for future references. Click on the notification bell so that you get notified when I upload a video. And please don't forget to comment if you have any questions. I'd be happy to read and answer your questions in the comment section below. And until next time, don't stop learning.